Hello my dear champions, welcome back to the channel. Today we are finishing the chapter application of derivative with the last topic at hand is maxima and minima. Okay, so we have covered all the concepts of this chapter. This is the end of it, maxima, minima. After completing this topic as well, chapter will be over, then we'll move on to the KCET PYQs. That works. Okay, so it is a fun chapter. As I said, it's high weightage, 4-5 marks comes from here. Sometimes it will be 3 marks as well, but you can expect 4 marks coming from this chapter, application of derivative. Okay, so I hope all of you excited for this, for the completion of another chapter in calculus. If you are ready for the session, comment right now. Ready, sir? Let's complete the chapter application of derivative. Okay, so if you see the session outline today, what is going to be done? Of course, we'll talk about what's the meaning of maxima, minima. What actually you mean by saying, sir, point of maxima, or point of minima. What's the actual meaning of this? Okay, then we'll move on to learn about simply, which is where the questions comes from, local maxima and minima. Means when can we call the given point as a local maxima and local minima. And over here only I'll give you hint about something called as absolute maxima minima. So not many questions has been asked on this, but I'll still give you some understanding, some information about absolute maxima and absolute minima as well. And lastly, we'll solve close to 10 questions, okay, on all these concepts. Clear? So you're gonna learn point of maxima, minima, basically the extremas, move on to learn about local maxima, local minima, where the questions comes from, and lastly we'll solve 10 questions from this topic to understand the entire concepts much with a better clarity actually. Okay, so I think we can start the session now. All right, now the point of me writing all these things over here, but you can see I don't read it for you, because rather this will become very helpful to all of you when you download the class notes. Okay, you don't have to make a separate class note. If you download the PDF of this session, you'll have everything ready with you, right? So this definitions helps you there. But do we have to read it right? Of course not. Let's understand the point of maxima with a very simple diagram. Let's make it a little bit fun. What is it? If you see, so whenever we talk about the maxima or minima, we talk with respect to any function, right? Any function means that function's maxima is at what point, that function's minima is at what point. So first we'll see only for the maximum. Okay, so what happens if you see a function like this? Let's say this is my function, okay, parabolic in nature, no problem. It can have a different part as well. Okay, so we'll see that later, but only this segment if you're looking at. If you can find a point, let's call this to be point A, where the function value is always more than the function value at any other point in that given interval. Means, of course, let's say we have an interval like this from here, let's call this to be B to C. Okay, let's say my interval is from B to C. We'll call it close and close. There's a difference. Okay, if there is a close interval, then the point of absolute maxima or absolute minima comes. If you don't have B and C close, then that one point is like the boundaries are not taken in the consideration. Okay, so if you see in the interval B to C, at the point A, function value of f of A is highest, is the maximum, then the point A becomes point of maxima, and f of A is nothing but the maximum value of the function in the interval I. That much is only there. Okay, so in the interval, of course there must be an interval defined for you. Okay, so in the given interval, if you find a value of a function which is highest, which is the largest, then that value becomes the maximum value, and the point where it is occurring is called as point of maxima. Please check. If f of A is larger than all the value of the function, what is this x? This x belongs to the interval. What is this interval? This x belongs to the interval A comma B. X belongs to the interval A comma B. See here, x belongs to the interval the I. Okay, I is defined like, sorry, not A comma B, B comma C. I made a mistake over here. Let me just correct that. The interval is not A comma B, sir, it is B comma C. Okay, I've taken in that fashion. Okay, so whenever you have this, then you call the function f of A to be the maxima function, and the point is called as point of maxima. Same will go for the case of minimum function. Okay, so let's say if I draw the graph over here as well, See this, the function reverses now. If you can find a point A in an interval defined to you, B to C, same thing, interval is defined like this, B to C, let's call it both closed, okay? And what is it? If you have the function fa, function value at that point A is always less than any value of the function at the point x, where x belongs to the interval I, basically x belongs to the interval B cross C, B comma C, not cross, B comma C. Clear? That's how we define it. That's what we define the function of minima. Again, same fashion. At point A, the value of the function is called as minimum value of the function, and the point A is called as point of minima. Okay, so that's how we define. Please check. F of A should be always less than the function value at any point in the given interval I. In the given interval I. Now, so in these points, okay, now we can have some points which can be neither giving me point of maxima or point of minima, okay, that is called as points of inflection. We'll see that later, not a problem. But any point, whether this point is point of minima, okay, or point of maxima, both of these are actually called as point of extremas, okay, or basically extremas. Both these points, minima and maxima, are called as point of extrema. And how do you find that? These are the critical points that you find after putting derivative equal to 0. Okay, that's how you find this. We'll see that. We have two tests to identify and learn today, which is going to be first derivative test and second derivative test to identify the point of maxima and minima. Okay, so that is clear, very much clear. Okay. So fx be a real value function on interval I, then fx is said to have extreme value in I if there exists a point in point A in I such that fx is either a maximum or a minimum value. Okay, so whether the maximum or minimum doesn't matter, but both of these are called as the point of extremas or extreme values. Okay, find the maximum minimum value of the function given like this. Okay, now when it comes to our mind, usually we look for any function with the help of derivative, because the chapter name is what? Application of derivative. So of course we'll try to differentiate this and get the answer. No need. We're trying to understand whether this function has a maxima or minima or not. Okay, what's the function given to you? Y equals to 3x square plus 6x plus 8. If you have learned the conic section in PU1 grade 11, you remember this is a curve of parabola, right? This is a curve of parabola. Quadratic equation, it's a curve of parabola. How do you solve this question? So what type of curve is this? Sir, a value here is more than 0, so concave up. Remember, concave up, the a value is more than 0, means concave up. Parabola goes like this, concave up. So of course for this kind of parabola, whatever it is, think about it, this will never have a point of maxima. Can you reach a maximum value in this parabola? Never, sir. You can never reach a point of maxima in this kind of parabola. Okay, so you have to find only, so you can write here, no point of maxima. No point of maxima. You can find only point of minima over here, which is this point. This point, right? This is the point of minima. You can see that in the curve. Okay, and what is this called as? This is called as the vertex, if you remember. This is called as the vertex, and we all know the coordinate of vertex. Yes, what is that? The x coordinate is given by, for the vertex, minus b by 2a. That's the x coordinate of the vertex. Can you find that from here? Please check. You're getting over here b value as 6, so minus 6 upon 2 times of 3. Answer is minus 1. So basically this point is nothing but the point of minima. Point of minima. So this given function does not have any point of maxima, only point of minima is there, and for that we know the vertex formula, x coordinate is minus b by 2a. Simply find f of this simple coordinate, right, minus 1. What are you going to get? This will become 3 times of 1, 6 times of this will become minus 6 plus 8. Answer is 8 plus 3 is 11, minus 6, so 5. This is my value of f of minus 1, which is nothing but minimum value of the function. Minimum value of function. There is no maxima, only minima is there, and the minimum value is 5. The minimum value is 5. Is that clear? Simple. No need to use always derivative in this. This is just to explain you the concept of maxima minima. Now when we go to the first derivative test, when we go to the second derivative test, then we'll see the applications of derivative there. Right now understanding what is the meaning of actually when we say a function has a minimum value or a function has a maximum value. So anybody who does not know derivative also can understand this part, right? Yeah, if you don't know the derivative principles, you can understand this whole concept by simply knowing the parabola. Okay, that was this example I have taken for. Let's move on to question number 2. Find the maximum and minimum value of the function given like this: y equals to sine of sine x. Again, this question has been taken for a sole reason of understanding what is the meaning of maxima and minima, not for the derivative point of view. You'll see that. So understand this. I'm looking for maximum minimum of this, right? But we have to define this part first. We know very clearly that for sine x, there is a range. There is a range for sine x, and what is that range called as? -1 to 1. -1 to 1 is the range of sine x. So in this part, if I put sine of -1, I'm putting this sine x as -1. Okay, and I can put y equals to 1. The extreme values. One extreme is 1. I'm getting this as minus sine 1 and this as sine 1. We know that this minus sign will come up, right? This minus sign will come out. Sine of minus x is what? Sine of minus x is minus sine x. Right? Odd function. It's an odd function. Okay. So you can see clearly over here, this is my minima value, this is my maxima value. This is my minima and this is my maxima. Again, I have taken a question where we don't need to use derivative to get the result, to understand the concept of minima and maxima. Just to getting used to what is the meaning of this concept is very, very important. It's very, very useful. You'll see that. Now we actually move into the real world of the problem solving for your KCET. This is where the questions are coming from most of the times. Okay, from this topic one question will come and that question will be solved on local maximum and local minima only. Okay, let's see. So same thing, similar curve. Let's understand first thing is local maxima. We'll try to understand local maxima. Okay, we'll draw a curve over here. We'll draw this curve again. So same curve? Yes, same curve. So again we'll write here this point, excuse me. Just give me 1 minute to draw this curve and we'll continue then. Let's call this point x equals to a. X equals to a. So now over here concept of neighborhood comes. Of course you know that we have learned that in limits. Remember in that also we have learned neighborhood of a point. Remember a minus delta and a plus delta. What's the meaning of delta? Delta is a very small value. I write here neighborhood of point A is given by basically a minus delta to a plus delta. What's the meaning of delta? Delta is a very small value, very, very, very small value. Okay, so we go over here and write here this point as a minus delta and over here this point as a plus delta. So local maxima concept is, the word is local. Local means only in the neighborhood, okay, only in the nearby region. So in the nearby region, if the point value at this point A is maximum, is highest for any value in the neighborhood of a minus delta to a plus delta, then that is called simply as what? Local maxima. Basically, if f of a is greater than f of x, where is x? X belongs to this neighborhood, a minus delta to a plus delta. Please check. X belongs to a minus delta to a plus delta, and of course x is not equal to a. Remember, neighborhood means what? The a is not there over here, okay? Because if you take that into account, what will happen? Then this will become equal to sign, right? So I have to remove that actually over here. Yeah, we'll not take the equality, we'll take only the greater than sign. Please check. So f of a is more than f of x. F of a is more than f of x. When you get that, sir, how is it different from what you taught us in the first slide? It's exactly the same actually, but it's basically talking about there's no interval defined over here from B to C. The interval becomes only the neighborhood. Sir, isn't that also interval? Yes, it is. You might ask me, sir, isn't that from here to here is an interval? Yes, it is, but we don't have to write and define that interval. It's simply called as neighborhood of the point A. What's the meaning of this? It means a very small value before that A and after that A. See the trend over here. Okay, now that is called as neighborhood of the point A. Clear? One second. Okay, so if you have this kind of trend, if the value of the function at point A is always greater than in any value coming across or in the neighborhood of the point A is called as, then the point A will be called as point of maxima, point of local maxima, and this will become what? Local maximum value. This f of A will become local maxima. Okay, similarly, very similarly, local minima also will have the same effect. Think about it. I think all of you will know now. Okay, if you have this point A given to you and you're defining a neighborhood over here, again this is called as A minus delta and A plus delta. Okay, then if you have these two, the neighborhood, then f of A should be what? Should be less than f of x for all x belonging to this interval A minus delta to A plus delta, the neighborhood of the point A. Now you might think, sir, isn't that the same thing exactly as the intervals? But when I'm writing this neighborhood, no, you said, sir, very close, delta is a very small value, then how come it is over here? This is just to explain you, actually delta is over here. This is the meaning of the neighborhood. The line you saw over here, this is the meaning of neighborhood of the point A. But to explain you, to make you understand, I've taken this little bit apart in the figure so that you can understand and relate to what is the meaning of A minus delta and what is the meaning of A plus delta. But actually when I say neighborhood, I mean that very small value close to A on both left and right side. Is that clear? Okay. This is the meaning of neighborhood of the point A, and that's how we understand and define the local minima in this case. This is called as, this f of A will become local minima. This f of A will be called as local minima. Please check. Local minima, and the point A will become point of local minima. Point of local minima. Now there can be a case where nothing is there. There can be a case where nothing is there. Okay, and that is called as, you can find a point where from which, so first of all your first job is to, a question given to you, from the question given to you, you have to list out what? You have to list out critical points. Critical points. Now few of these critical points can be local minima, few can be local maxima, and other can be nothing. That is called as point of inflection. Point of inflection. So what's the meaning of this? I can draw a figure for you and you'll understand from there. So please check. So over here, if I draw it like this, check this out. This is my local maxima, local minima. This is my minima, right? This is my local maxima. Local maxima. Okay, and this over here you can see where the change is occurring. This is called as your point of inflection. Point of inflection. Okay, now I want to tell you one more thing about the concept of, absolute maxima also. Over here only we'll take one more figure to understand that as well. Let's complete that part here itself. Okay, so I'll draw another curve like this. So where you'll see I have one local maxima over here, then local minima, then I have another local maxima, then I have local minima, then I have another local maxima, and then again local minima, and like this. Okay, so please check over here clearly. We have total of 3 local maximas, right? This is max, this is max, this is max, and we have minima also 3. This is min, this also is min, and this also is min. But if I have to ask you which is absolute maxima, then of course this will become absolute. Absolute means that out of the all local maxima that you have, which is the largest, okay? So your absolute maximum will become this value. So can you see the peaks over here? Then again we go up, This is the absolute maximum value. Similarly, you'll have also absolute minimum value. So out of all the minimum values, which is the smallest, please check. Minima, this will become your absolute minima. That's it. That's the concept of absolute maxima and absolute minima. So in all the given maxima value, which is the largest, that becomes your greater maxima or absolute maxima. And similarly, of all the minimas, whichever is the smallest becomes simply the absolute minima or the greater minima. Okay, this is clear now? All right, let's move on to now if a question is given to you, how do you know all of this? How do you actually solve the problem? So far concept part is okay, understood sir, no problem whatsoever, but how do we get to solve these questions? How do we solve these questions? So for that we have two tests, first derivative test, and we also have second derivative test. Now usually I'll recommend you to use this one because this is the faster one. I'll recommend you to use the second derivative test because this is a faster version of finding the local maxima, local minima. But sometimes it is difficult to find the result with the help of this test. Then you can come back and understand this trend using first derivative test. So basically, in 90% of the cases, you can simply use this test, 90% of the cases, to get the result. But some questions you might have to use this also. So basically, I'm asking you to remember both of these, but give more practice to this one, because this is the faster method. Now all of this is written over here, it's okay. I'll explain it to you, then you can come back and read this pointers given to you. The pointers are for your benefit to make sure that you have the complete notes with you. Okay, going for first derivative test. All right, so what it means is, understand this clearly, if you draw a curve like this. Now after drawing this curve, I know all of you will say this is a local maxima, right? If I have this curve with me, this means what? This is a curve of local maxima. All of you will agree? All of you will agree? Yes? Okay. Now, so first derivative test actually tells us, if you're talking about this point, x equals to a. If you're talking about this point, x equals to a. So in the neighborhood of the point A, neighborhood means just before, just after, was the slope trend. Okay, basically find a slope of a point which is before this, you'll have this slope. Please check. Correct, now that's why you find slope. To find slope, what are you going to do? Find the tangent, right? This is your slope. That's my slope, right? That's my slope. Where? In the left neighborhood of the point A. What about right neighborhood? What about the right neighborhood, sir? So difficult, na? That's my slope. That's my slope in the right neighborhood. Think clearly again. For this part over here, what is that you have? This part represents, please check, slope. Okay, for that you have acute angle, and this means basically positive slope. Tan theta, right? Tan of acute angle is positive. This is a positive slope. And for this part, what you have? For this part you have slope as of obtuse angle, and basically it's given as negative value. This slope is negative. Remember, y equal to x curve was this. This is y equal to x curve, positive slope, and y equal to minus x curve was this, obtuse angle, y equal to minus x, right? Correct now? All positive slopes are always based on acute angles, whereas all the negative slopes are always based upon, so this angle is wrong actually, it's taken from the x-axis, not the line itself, excuse me. So all the negative slopes are taken from, of course, x-axis, it will be based upon the obtuse angle. This is clear. So clearly in the case of local maxima, I am having the slope change from where to where? From plus to minus. Right neighborhood of the slope, right neighborhood of the point A, slope is negative. Right neighborhood of the point A, slope is obtuse, so negative. Left neighborhood of the point A, the slope is positive. So the slope changes from where? Please check. The slope changes. So the slope changes from plus to minus. The slope changes from plus to minus, positive to negative. What's the slope called as in case of calculus? Slope is nothing but, remember, dy by dx. What is slope called as? dy by dx. So basically dy by dx changes from plus to minus. So whenever you have this, what is this called as? This is called as first derivative, right? This is nothing but first derivative. So whenever your first derivative changes the sign from plus to minus, I'll repeat, whenever your first derivative changes sign from plus to minus, then what happens is your given point A is actually point of maximum. In the neighborhood of the point A, I'll repeat, in the neighborhood of the point A, if your first derivative, what is that? Slope changes sign from plus to minus, the point is going to be local maxima. Clear? If you are watching this video right now, repeat this statement with me. Please repeat. I know you are at home, it's not a live session, it's okay, but repeat after me. In the neighborhood of a point A, repeat, in the neighborhood of the point A, if you have the dy by dx, which is slope, sign change from plus to minus, sign change from plus to minus. So in the neighborhood of the point A, the dy by dx, the first derivative change sign from plus to minus, the point becomes local maximum. The point becomes local maximum. Let's see the case of local minima now. Was this not fun? Tell me. Was this not fun? Of course it was, right? 1 second. Let me draw the curve again. So we have just opposite case, sir. Local minima now. You're talking about local minima now. Local minima. Okay. Now in this case, you see, if I identify a point over here as point A, neighborhood of the point A, right before, what do you have? The curve is like this. The curve is like this, okay, the tangent, and after this, right neighborhood, the point is this. Understand this. Over here, slope is acute angle. Over here, slope is obtuse angle. Okay, you can go over this. Slope is of acute angle, basically positive, and over here we have slope and on the obtuse angle, which is nothing but negative. So same thing, please check the slope changes from where to where? From minus to plus, minus here to plus there, minus to plus. So whenever you have slope change from where to where, minus to plus, that will give me what? That will give me basically, slope means dy by dx, sir. We know that very well. I've taught you that. I've taught you rate of change. dy by dx change is from where to where? From minus to plus. That is called as your local minima. Please check. Slope is basically dy by dx. So after doing the first derivative test, if you find the slope changes from minus to plus, that is called as local minima. I hope this is all clear now. Simple, very simple, right? Okay. So download this class notes, the PDF form of this, and revise through the concepts, okay? And then you can of course solve the questions as well. So this is, I've talked about local minima over here, and over here I've talked about local maxima. If you want, you can read this. If you want, you can pause the video and read this, and over here do the same thing. Pause the video and read this, or simply download the PDF and get the result. Okay, first step will be to find the derivative. Why we do this? To find the critical points. What is this called as? Points of extremas. Okay, whether minima or maximum, we'll see that later. Whether this point turn out to be minima or maximum, we'll see that later. This is called as extremas. Already taught you this today. Extremas. Point of extremas. Okay, you find that. That's not visible actually. I'll write it better. Point of extremas. You're gonna find this. There can be either minima or maxima. We'll see after you get this thing. Sign changes from where to where? Plus to minus. Okay. Great. Sign changes from negative to positive for minima and positive to negative for maxima. Okay. This is for if you have no sign change. If you have no sign change, this is called as point of inflection. This is called as point of inflection. Steps remain same. I'll show you like this. The graph came like this, let's say, and went like this. 1 second, I can do better. Yeah, I can do better. 1 second here. Please check this point. This point over here. Before this also you have what? You have here positive slope. After this also you have positive slope. Draw this. You'll have positive slope like this and like this. I'm not saying the slope is same. I'm saying that slope are both positive. It means the sign changes from where to where? Plus to plus. So no, this is called as point of inflection. This is called as point of inflection. Okay. Now moving to the question number 3, which we're going to solve with the help of first derivative test. Okay, let's continue. Find the points of local maxima, local minima and point of inflection for the function given like this. Okay. Step number 1 remains same, dear. Step number 1 remains same, finding derivative. That's my step number 1. Okay. Step 1 is finding derivative. So 5x power 4 minus 20x power 3 and plus 15x square. We can take something common over here, right? Take 5x square common. We get here x square minus 4x plus 3. X square minus 4x plus 3. Rest is what? Factorization. So factorize it. Factorize it. You get over here x minus 1 and x minus 3. Please cross check. Minus 1 into minus 3 is plus 3. Minus 3x minus x becomes minus 4x and x into x is x square. So now we have the factors with us. Next step is to put this equal to 0. Put this equal to 0. Put this f dash of x equals to 0. When you do that, you get critical points. Please check. One of the value. How can you make this whole thing 0? Take x as 0. If you take this as x as 0, the whole thing will become equal to 0. Or take x as 1. Put x as 1 over here. This whole thing is 0. X as 3 you can put. So you have this as critical point. This is my step number 2. Okay. Step number 2. This is called as what? Critical points or point of extremas. Critical points or also called as extremas. Okay. Called as extremas. Alright. So this step 2 is also clear. Now step 3. What is step 3? Wavy curve method. Step 3 is wavy curve. Basically number line. Please check. Number line. Over here. What you have the points written like this 0, 1 and 3. Factors, look at the factors and see the sign of x, coefficient of x. Here coefficient of x is positive, here positive, here positive. Means all is positive only. Start from plus sign. Start from plus sign. The 3, where the factor is going to give me 3 value as x critical point. For that, what is the power? Power of this factor is what? 1. Odd or even? Odd. Sign changes. Minus sign. This case, 1. Factor is what? X minus 1. What is the power? Again 1. Sign changes. Plus. Now 0. 0 comes from x square. 0 comes from x square. Power is 2. Power is 2. Please check. Power is 2. It means even. Sign remains same as plus. Whenever you have the factors power as odd, 1, 1, odd powers, sign alternates. Okay. But if you have the power as even, sign changes. Sign remains same. Okay. Sign remains same. So you have this now. Please check for each of the critical points. For the point 3, sign change, dy by dx sign change you check. What is it? Minus 2 plus, minus 2 plus, minus 2 plus is local what is called? Local minima. Local minima. Okay. Point 3 is local minima. Oh. Moving on to point 1 now. Point 1, sign change, plus to minus. Before 1, plus. Before, after 1, minus. This is my, so your dy by dx sign change is what? It's going to be plus to minus, right? Plus to minus. Please check. Plus to minus, 1 second. 1 second here. Plus to minus over here. Plus to minus is local maxima. Plus to minus. Plus to minus is local maxima. Okay? Super. Let's move on. Plus to minus is local maxima. We get here local maxima. The last one 0. The last one 0. Have a look over here. Plus to plus. Plus to plus. Sign change. It means simply called as inflection. Point of inflection. You don't have any value only over there. You don't have either maxima or minima. So at point 3 you have local minima. At point 1 you have local maxima. At point 0 you have inflection, because sign changes from where to where? From plus to plus. Before it is plus, after it is plus, sign changes plus to plus. In the case of point 1, plus to minus. In the case of point 3, minus to plus. You can see the sign changes now for the derivative and get the result as local maxima, local minima and inflection. Now this is homework for all of you over here. Homework is to comment below maximum and minimum values of the function. Okay, so please comment below. I'm not going to solve it. What are you going to do? Simply take the 3 value in the function, find f of 3. You'll have something value coming out of it. That will be your local minima, or basically f minimum. And if you do put x value as 1, you'll get what? You'll get some value that will become local maximum. So give me the value of local minima and local maxima in the comment section right now. Okay, pause the video, solve it, and give me the values. Okay, so done. Let's move on to question number 4 now. Okay, not 4. Before that, we have the simplest method to understand, which is, I told you, sometimes in this question it is easy, but in some questions it will be difficult to identify the sign change. And then comes our Masiha, the help who gonna help us in all the questions, called as second derivative test. Second derivative test. Okay, very simple. Simply do the derivative 2 times. First derivative, step 1. First derivative to find out f dash of x, you're gonna find out. Put it equal to 0. Put it equal to 0. What are you gonna get? From here you'll get it as extremas. You'll get extremas. Remember, you'll get the critical points. Step 2. Put the do the second derivative. Okay, you're gonna find the second derivative. In that, let's say extrema values are a and c. Check this out. If f double dash, the step number 3 is, if f double dash at point A is more than 0, and f double dash at point C, I've taken 2 extremas, right? A and C. At C is less than 0. When you have more than 0, it means it's local minima. Local minima. When you have less than 0, means it's local maxima. Local maxima. So step number 1, to find the first derivative and put it equal to 0 to get the extremas or critical points. Step number 2, find the second derivative. Step number 3, put the critical values in the point. If you get more than 0, it is local minima. Less than 0 means it's local maxima. The point will become local maxima. Please check. If it is less than 0, it is local maxima. If it is more than 0, it will become local minima. Okay. If it is equal to 0, means you have to go back and use the first derivative test. If it is, let's say, if the first derivative is 0, put it over there, and second derivative is also equal to 0. So what are you going to do? You have to use the first derivative test. Go back and use first derivative test and see the sign change. That's why I said for some question it is difficult to do that. Alright. So let's move on then. Now solve a question based upon second derivative test. Find the maximum and minimum value of the function given like this. First step is very simple. Find the y dash. What do you get? 15x square plus 4x and minus 3. You have to put this equal to 0 to find the critical points or the point of extremas. Factorize this. I have 45, right? Multiply these two, you get 45 over here. So you can write here 15x square plus 9x minus 5x minus 3. Am I right? Yeah. So please check. I get 5x common over here. So it becomes, 3x common, right? Not 5x. My bad, dear. 3x, not 5x. This is 3x, okay? This 3x. I get 5x plus 3. Take minus sign common. Minus 1 is common actually. So minus 1 common. I get, 1 second, it's not clearly visible. Okay. Minus 1 common, I get 5x plus 3 equal to 0. My factors are very simple. 5x plus 3 and 3x minus 1. From here you can get the extremas, the critical points. From here you get x value as minus 3 by 5 and x value as 1 by 3. These two are my critical points. Step number 1 is done. Step number 2, to find second derivative. Step 2. Step 1 is over. Step 2 is to find second derivative. Find it from here. You get this as 30x and you get this as plus 4, right? That's my second derivative. The step 2 is also over. Step 3 now, simply find the second derivative at the critical points individually. What I get? 30 times of, at the point, what is it? Let's say I use 1 by 3 over here. So I get 30 times of 1 by 3 plus 4 to 10. This will be 10, right? 10 plus 4 is 14. 14 is more than 0, means x equals to 1 by 3 is what? Is local minima. Is local minima. Is local minima. All right. And again y double dash at the point minus 3 by 5. If I use that, I get 30 times of minus 3 by 5 plus 4. 5 into 6 I get over here minus 18 plus 4 is nothing but minus 14, which is less than 0. So I get x equals to minus 3 by 5 is point of local maxima. Local maxima. Please check. Okay, of course they're asking you the maximum minimum value. That is your work to do. That's your homework. Again, one more homework over here. Sir, why? I think you can do the calculations, right? No problem there. Homeworks. Give me the value of f max. Okay, f max is equal to what, and f minimum equals to what? Please comment below for the question number 4. What is the value of f max and f minimum? How are you going to do that? Put the value of 1 by 3 over here in the function and minus 3 by 5 in the function. You'll get the answer. You'll get the answer over there. Please check. Find the value of f max and f minimum and give me answer in the comment section. So far I've given you 2 calculations, so please do it. Please do it. Okay, do not miss out on that. Question number 4 is done. Question number 5 now. 4 is clear. Homework is clear. Now this is a very good question. Very good question. For that I'll need your attention completely on the board. Right now put your pen down and complete attention on the screen. Let's read the question. An open topped box is to be constructed by removing equal squares from each of the corner of a 3 by 8 rectangular sheet. Rectangular sheet. This is 3, this is 8. We are supposed to remove equal squares from each corner. Remove, 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 remove. Okay, if you remove this part over here will become wall, right? 1 second. This part over here will become the ball, no? These 4 parts will become wall, right? And this will be your base. The other part will be your base. I hope all of you can visualize it. This will become your base, right? For the given figure, for the given box. This will be the base, the bottom part, okay? And this things will become wall. This will come up. This will come on the left side. Again come up, and then on the right side it will become a wall. Okay, so you'll have an open box. You'll have an open box like this. Please check. You'll have an open box like this. Okay, you'll have an open box like this. Correct? That's how it'll look. If you create it, that's how the box will look like. Okay, not perfect, accept my figures, they're not as good, I understand that, but it's okay. All right, so if I'm looking for the dimensions, if I'm looking for this part, how much is this going to be? This is going to be what? The remaining part over here, I'm taking, let's say this is x and this is also x. This is also x because they are squares. So x, 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 x. So if you look at this carefully, what happens? This part over here will become 3 minus 2x. This part will become 3 minus 2x, the smaller wall will have a width of 3 minus 2x. Same way, this part over here, this part will become what? 8 minus 2x. So I have for the box length I have, breadth I have, and what about this height? This will become simply x. Because this, please check, this part is also x, right? And they will come up. This part over here will come up. This over here will go up like this. This over here will go up like this. It was like this, no? It came up like this. It becomes the height. So height part is going to be x. So for the given open box now, open topped box, I have the dimension. Length is 8 minus 2x, width is 3 minus 2x, and height is x. I hope everybody is clear how I got 8 minus 2x, 3 minus 2x and x. Okay. Now from there, find the volume. Because they're asking us first, find the volume of the largest such box. Largest such box. Okay. You have to find the volume. How do you do that? V equals to this thing. I get this as 3 minus 2x into 8 minus 2x into, what is it? X. Okay. This is clear. This is the volume. Now rest is simplification. Okay. Rest is simplification and calculation. Let's do that. I get V equals to, multiply this. I get 24 plus 4x square. Correct. 4x square. 8 into 3 is 24, minus 2x into minus 2x is 4x square, and I get 8 into minus 2x is going to be minus 16x, and 3 into minus 2x is going to be minus 2x, sorry, minus 6x, my bad. Minus 16 and minus 6 will become minus 22. If you're not sure, pause the video and do your own calculation right now. Minus 16 and minus 6 becomes minus 22x. This clear? That's my the brackets expansion. We have x outside, write volume as I'm going to write this as the highest order first. So 4x cube, highest degree will come here, 4x cube minus 22x square, and we have next is 24x. Okay, that's my volume expansion. Okay, that's my volume form. Equation required for volume. Now volume function is defined. I'm looking for what? I have to maximize this. I have to find the largest value of the volume. I have to maximize this. It means I need to find the derivative of this. I have to find the critical point for this. So simply do that. dv by dx. You get here 12x square minus 44x plus 24. Okay. Now we have to find the critical value. So put it equal to 0. We need to find the critical value, so put it equal to 0. Derivative we found, and put it equal to 0 to find the extremas, the critical values. I have something common over here. I think 4 is common. I get here 3x square minus 11x plus 6 equals to 0. Bring this 4 on this side. My question is what? So far I have 3x square minus 11x and plus 6 equals to 0. Please check once again. 3x square minus 11x plus 6 equals to 0. I've taken this 4 on this side. 0 by 4 is 0. Great. Factorize this. So I get here 3x square minus 9x minus 2x plus 6 as 0. Correct. Minus 9x minus 2x is simply 18x, which is 18x square, which is the product, and the splitting is done. To add it, get as 11x. Okay. 3x is common. I get x minus 3. Minus 2 is common. I get x minus 3. Once again 0. So I have the answer here as x minus 3 and 3x minus 2 equal to 0, giving me x values as either 3 or 2 by 3. I have two extremas known now. I have to find which one is maxima, because I'm looking for largest volume. I'm looking for, so what is this going to be? What is 3 and 2 by 3? 3 and 2 by 3 is the side length of that square you took out. 3 and 2 by 3 represents the side length of the square you took out. Remember the figure. This is a rectangle, right? Not clear, no. Square you took out from here. Remember? This was x over here. Remember, this was the square you have taken out from here. This is also x. Okay? This whole thing was 3. You've taken out this 2 x's. It'll become what? This will become 3 minus 2x. This whole thing. Over here, you'll have this as 8 minus 2x, because whole thing was total 8. You've taken x from here, 8 minus 2x, 3 minus 2x, and this is the height. Right? So this x that you're getting is nothing but this value of the edge of the square. It can be either 3 or 2 by 3, depending upon which is the local maxima. I have to find the local maxima over here. Once I can find the local maxima, then I can identify which is the actual value of x. Okay? I can erase this now. This is just for explanation. If the other figure was very simple or very smaller for you, I wanted to explain this again. Okay, 1 second. Alright, just give me 1 minute to erase all of this. Okay, just a minute, guys. Alright, I think this is clear. I hope the figure part is clear now. Yes. So I have to find the local maxima and local minimum value. What do you do that? You have to find that's excuse me, the function is different, right? The function is now d square v upon dx square. The differentiating what? We have to differentiate this d by dx of the volume, first derivative. What is that? Over here we have this 12x square minus 44x and 24, right? 12x square minus 44x, and we have 24. Differentiate this, you'll have the answer as 24x minus 44 as my second derivative. Looking for extreme values now. Okay, so we can call this as to be v double dash at the point 3. At the point 3, please check. I get 24 into 3 minus 44. How much is that? 72 minus 44. Correct, na? This is of course more than 0. This will become what? This will become local minima. Do I want this? No. We don't want the minimum value, we want the maximum value. So we have to move on from here and find double dash at the point 2 by 3. What do we get? 24 into 2 by 3 minus 44. 3 8s are, I get here 16 minus 44, which is of course less than 0. Now this point x belongs to 2 by 3 is the local maxima. Okay, local maxima. What are they asking us? They're asking us largest volume. They're asking us largest volume. So what is that going to be? V value, the volume value when x is equal to 2 by 3. What is the volume value? We have a volume expression actually. That is coming as 4x cube minus 22, 4x cube minus 22x square plus 24x. So substitute this x over here. Try 4x cube minus 22x square plus 424x. Substitute x value as 2 by 3 in this all the functions. Substitute the x value as 2 by 3 and give me the result. Right now, comment right now the result of maximum value. We're going to be V max. Give me the value. I think this should come as, not sure, but I think it's going to be 200 by 27, something like this. Okay, excuse me. Check once please. Calculate once. Okay, this is homework again. Please check whether this is right or not. 200 by 27 is right or not. If you put x value as 2 by 3, whether this is coming as 200 by 27 or not. Please cross check. Done. This is clearly visible. Okay, let's move on. One more time, you want to see everything from here as well. It's a beautiful question. You have to of course solve it faster to get the result, but I have taken a question which will also be useful in your boards part as well. Okay, so now moving on, this question is MCQ. Let's solve this. This is a fast question, very simple question. Function is given over here, f of x. Check this out. If I write like this, 2 by 3 minus 4, 2 by 3 minus 4. If I do this, is it all right? It will become 2 by 3 and x power will have minus 1 by 3 minus 0 of course. This will become 2 by 3 and x power, it will become x power here 1 by 3, right? 2 by 3 minus 1 will become what? My 1 by 3. Okay. Now if you put this equal to 0, can you do that? This can never be 0 value actually. If you put x as 0, it will be undefined, but we don't have to worry about that because they have given x is more than 0. It's not equal to 0, okay? So we don't have to worry about this. This is my f dash of x, okay? This is my f dash of x. Alright. So my f dash of x is nothing but, please check over here, it's coming as 2 by 3, which is a positive number, and we have 1 by x power 1 by 3. Basically, cube root of, you have cube root of x. You have the cube root of x left over here. Cube root of x. Okay. So think for all x value more than 0. For all x value more than 0. Won't this always be positive only? 2 by 3 is a positive value. If you take cube root of any positive value, 8 you take, anything you take, 64 you take any positive value which is more than 0, of course, cube root will become again positive only, right? So basically this derivative is always positive. For all x greater than 0, this derivative is always positive. F dash of x is always positive for all x more than 0. What happens is always increasing in nature. Can you get extreme point in this? Can you get a minimum maximum in this? If you have a graph like this, always increasing. Do you have a maxima minima over here? No. If the function is of only one nature, always increasing, then you cannot have, what do you have? You cannot have, what is it? Maxima and minima. It means neither local maxima nor local minimum value. Option C is correct. Clear? Is it clear? Since the graph is increasing in nature, even if it was decreasing in nature, let's say if I have the graph like this, decreasing in nature, can you have a local maximum, local minima? You can never have that because you keep moving forward, the value will keep decreasing. So you don't have any minimum value. Same goes with the case of increasing also. There is no local maxima minima if the graph is either increasing or decreasing in nature. Okay, done. Sixth question is very simple. Option C is correct. Clearly visible. Question number 7 now. Find the height of the cylinder which is open at the top. Cylinder open at the top. Okay, and here it is closed. Having surface area as S, surface area. So the surface area, you'll have this, right? You'll have 2 pi RH and you'll have this pi r square. That's all. You will not have the top area because it's open, right? So there's no top area. So you can write this as 2 pi RH plus pi r square. That's my surface area. Works. They're saying that having surface area as S, greatest volume, okay. So surface area is S and volume is maxima. Surface area is S and the volume is maximum. Then find the radius R. Find the radius. Okay. The radius is also given as R. Forgive me. They have given us 3 things. Forgive me. They have given the surface area is S, volume is maximum, and your radius is R. And what are they asking? They're asking us to find the height. Find the height. Let's do from here. We can get this. We'll have S minus 2 pi R square. Sorry. Not 2 pi. Pi r square. Bad habit. Its top is open, right? Yeah. So S minus pi r square equals to 2 pi RH. So I get the value of H as S minus pi r square divided by 2 pi r. That's my height value. First part is clear. This much is clear. Next one. We'll have to find volume. Volume of a cylinder is given by pi r square H. Okay, differentiate this. We'll have dV by dr. This will become what? 2 pi r square. Okay, sorry. I have to find the value of S over here, right? Excuse me. We have H. We have to remove the H as in terms of R, right? We don't have 2 variables over here. We have to simplify this in terms of R first. Excuse me, guys. Okay. So write V as, 1 second, put the value back. Pi r square, H value is S minus pi r square divided by 2 pi r. So pi cancels, r also cancels. What I'm getting here, V equals to 1 by 2 r times of S minus pi r square. S minus pi r square. Okay, r is cancelled, right? One of the r. Alright. So what I get for the volume, please check. I'm getting 1 by 2 SR minus pi r cube. Okay, differentiate this now. dV by dr to find what? To find the critical points. Okay. Okay. What we're getting, 1 by 2 is a constant. For this I'll get S because r will be 1, right? Derivative of r will be 1. S is already that as simply as S. And for this I get what? I get 3 pi r square. Simple as that. How do you find the critical point? Put it equal to 0. 1 by 2 S minus 3 pi r square. Clear. So far we are trying to get the critical point. Okay, please check. I'm getting here 1 by 2 will come over here, will become 0. I'm getting the value of S as 3 pi r square. Okay, we have only one critical point over here. S as 3 pi r square. S as 3 pi r square. Clear. Okay, so when I try to maximize the V, I had to find the derivative to do the process, but in between we got only one critical point as S equals to pi r square. Now we can see, we can substitute the S value over here and get the result for H. What we are looking for? We are looking for the height value. We are looking for the height value. Okay, so to find the height, please check. I get 3 pi r square minus pi r square divided by 2 pi r. Difference of this will become 2 pi r square divided by 2 pi r. 2 cancel, pi cancel, and r will also cancel with this, one of the r's. I get the height value is equals to actually r. My answer is option A. My answer is option A. Please check. It's a very simple but beautiful question. Can trick some of the students. Do not worry what they're asking, what they're giving. That's the one thing that you should be very much clear about. Okay. What they're saying is open top. This is not there. This is not there. Means surface area will become pi r squared plus 2 pi rh. This is CSA as 2 pi rh, and the part is pi r squared, the bottom surface circle area. From there you can find the H value. You get the H value, put that back in the volume formula to get that whole thing in terms of S and R, because they've given S value. H is unknown. H is not known. They've given only S and the radius. Okay, so you find the volume in terms of S and the radius, differentiate this, you get what? You get R. Alright, now you might think, sir, why I'm not putting S back in terms of the expansion that I have? There's no need, because we are trying to figure out the value of S. Yes, you might want to think that 2 pi RH plus pi R square, we should put it back over here, right? S, because even S has something in it. Okay, but S is a constant given to you. S is a constant given as surface area. Think, surface area is given as S. It's a constant value. Why putting back in the terms of the variables? S is the surface area given to you, so put it as a constant, differentiate this. Okay, otherwise you might be thinking, a student who's good in mathematics will think like this, sir, S is a variable. No sir, S is given like this, differentiate this also. No sir, differentiate this, sir, differentiate this, sir. No need, because S is given as a surface area, as a constant. We are getting the result of S in terms of the value R. Okay, so we got the result S equals 3 pi R square, put it back over here to get H value as equal to R. Is it a good question or not? Let me know. You had fun? Did you had fun? 7th is clear, right? 7th is clear. No problem here. Class notes you have to download to get understanding of entire thing again. Practice this question number 6 and 7 one more time. 6, 7, and there was I think 5, 6, 7. Practice these questions one more time. 8th one, maximum value of the function this. It's very simple, right? Find f dash of x, it'll become 1 by 8, and you'll have over here, okay, this is not a simple question, this is a very good question, because they've given an interval, and they've given this is closed interval 1, 6. It means we have to find the function value at 1 also, because at 1 function is defined. It means it might be a local maximum or local minima, right? If the function is, let's say, like this, okay, starts from the point here, okay, let's say this point is more than this, right? I get a maximum over here, but this point is higher than this. This will become my absolute maxima, correct? So we need to find our extreme values, the function value at the point 1 and 6 also. We cannot just find the critical point. I'll show you. Find this, I get 1 by 8 and I get minus 2 by x square. That's why I find the derivative of 1 by x, 2 is a constant. Derivative of 1 by x is minus 1 by x square, okay? Put it equal to 0, I get 1 by 8 equals to 2 by x square. From here I'm getting x square equals to 16. I get x value as plus minus 4, but I have only 1 because I'm looking for 1 to 6. So x cannot be equal to minus 4, okay? I have the interval defined to us, 1 by 6. So I have total of 3 extremas now. I have x equals to 1, x equals to 4, and x equals to 6. I have 3 extremas now. I have 3 extremas now. Yes, find at 4. Do this. I get 4 by 8 minus 2 by 4. 2 by 4. Please check. Sorry, plus. I get 4 2s and 2 2s. Answer is 1. So value of the function at 4 is 1. Okay. Over this at 1, I get 1 by 8 plus 2 by 1. How much is this? I get this as 2 plus 1 by 8, so 16 plus 1, 17 by 8. Of course, this is more. This is 1. This is more than 2. This is more than 2, right? This is higher. What about 6? Please check. I get 6 by 8 plus 2 by 6. LCM is what? LCM is 24. Okay. So I get 6 3s are 18 and 6 4s are. So I get 8. So I get 26 by 24. It will become 13 by 12. So it will become 13 by 12. Okay, check this out. Which is more? This is 1. This is just more than 1. This is more than 2. Answer is option D. Answer is option D. Actually, after getting this value, you can directly write the answer. After getting this value, you can write the answer. Because this is, of course, more than this. And of course, this is more than this. This value, even if this was, let's say, your second option, this is highest value. This point is coming as the value of the function at the point 1. And this is more than all other 3 options. Of course, option D has to be correct, right? Think logically. No need to find this part. After finding this one, you get the answer. So actually in the question, you don't have to find anything, because if you don't have to find a derivative also. Whenever you have a closed interval given to you, find first thing as f of A and f of B. If they're asking you if they're asking you maximum minimum value, find f of A. If this is, let's say, maximum And if this is maximum of all the options, they're asking you local maxima, they're asking you maximum value of the function, and the value of f of a is maximum of all the 4 given options, the answer is f of a, right? Why finding derivative? You don't have to find derivative. Check here. F of 1 we found. If I find f of 1 first, I get this as 17 by 8. Right or not? And check the options now. They're asking us maximum value. And f of 1 is 17 by 8. Of course, it has to be the answer. Why we find derivative? We don't have to find derivative at all. Okay, because 1 is part of the interval, and at 1 I get the value 17 by 8. They're looking for maximum value, and this, out of the given 4 options, this is the highest. It means that my answer is option D. No need to find the derivative. Okay, question number 8 is over. Please check. Question number 9 now. Fx equals to x square and 2 sin x when x is less than 0 and greater than 0. Okay, discontinuous? No, this is wrong, right? It's a continuous function. If you put limit value going to be what? Limit value going to be 2 sin 0, right? You'll have the answer as 0 only, no? And function value at 0 is nothing but 0 square, 0 only. So continuous. This option is wrong. Option C is wrong. Okay. Now minimum maxima. Minimum maxima. Please check. Minimum maxima. Let's draw this. Can you differentiate this? I don't think so. More than 0, the graph is this, right? That's my graph. More than 0, 2 sin x. At more than 0, graph is 2 sin x. 2 sin x. Use logic. 2 sin x. Sir, the graph is like this for sin x. Multiply a constant. Doesn't matter. The graph will not change. The nature of graph will not change. Of course, this value will become equal to 2. So what? This becomes equal to 2. So what? The graph will change. No. The graph nature remains same, 2 sin x, as it is. So I have this as my graph. 2 is the value. Okay. Right hand side. Right hand side. What about left hand side, sir? X square. That's the parabola. X square. Of course, you can see here there's a sharp corner. Sharp corner. So if there was a given point as non-differentiable, actually this given function over here is non-differentiable. Because usually what will happen, no, you'll try to start differentiating it. Because to get the point of minima and maxima, you have to differentiate only, right? You have to find the critical point, you have to find the first derivative, second derivative, whatever you are doing. Then you have to check this graph is getting as a sharp corner. So given function is non-differentiable at the point x equal to 0. At the point x equal to 0, the given function is non-differentiable. Non-differentiable, it means what? It means you can't find this approach of first derivative test, second derivative test. Can you do that? You can't differentiate the function. Then how do you do the first derivative test? How do you do the second derivative test? You cannot do that. Okay. So non-differentiable. So sir, answer is none of these. So we can't differentiate. It is continuous, so we can't have the option C. So answer is D. No. Check the graph. No. This point at point 0 is what? Is a point of local minima. Is a point of local minima. Option A. Getting it? So even though we cannot find the differentiation of this, but we can see from the graph, it is a point of local minima. Answer is point of local minima. So even though the function is not differentiable, I can see from the graph is creating a point of minima at the point x equal to 0. My answer is option A, not D. Not D. Usually what will happen, no, you'll say that you can't differentiate it, you can't find the derivative, you can't find the minima maxima, hence answer is option D. No. Answer is option A, point of minima. Look at the graph. So I don't know the graph. What you don't know? Y equal to x square is a parabola. On the left of 0 we have parabola. Right of 0 we have sin x. You don't know the graph of sin x. You don't know the graph of parabola. Of course you know. Just trust yourself that you know it. Okay, you just don't, you're not able to apply it. You know the graph. Yes, you have to apply this as well. Okay, you get the graph. There's a sharp corner. This is a corner only, right? This is the edge corner. Of course, there will be non-differentiability, right? Option is what? Your option is actually A, point of minima. Question is done. This was a simple but a very beautiful question, and it completes our session today. I hope you had fun. I hope you had fun. I had fun teaching all of you in the session where we talked about maxima minima as subtopic of the chapter, application of derivative. Our chapter is over. We have one more session coming in this chapter which is going to be what? KCET PYQs. Okay. So that is it for today. I'll see you again very soon. Till then, of course, you have to take care of yourself. Keep working hard. Keep smiling. Take care. Bye-bye.